Okay, you guys can turn in your math books to chapter 5. That's where we're going to start today. We're just going to kind of get through this pretty quickly. My suggestion for you guys that are online is to, you'll go through this chapter 5. I'm sorry. Oh, yeah, chapter 5. And go ahead, and what I did was I printed and made copies of all of the conversion charts that are in here, like the one on 127, kind of like a yellowish color. There's one on 132. There's another one on 136. I made copies of all those, and then I printed them, and then I made copies, printed them, and then I put them all on one piece of paper, so that way you got that you can use to go by. Some of them you really do need to memorize, the ones that you use often, but some of them are not. It's not really necessary to memorize them. Okay, so we will kind of start. Go ahead and start on page 120 where it talks about the keywords. There's a couple of things on here. This first measurement system that it lists on here is one that we don't use very often. Well, I say that, take that back. We use it often, but we don't necessarily convert to it really often. So you've got your weights that we use, your pound, and your ounces, like 16 ounces in a pound. And then you've got, it says 7,000 grains equals 1 pound. So you've got grains as well. Now the next term on here is dimensional analysis. So it says the mathematical means of manipulating units of the dimension given to the numbers to cancel unwanted units when you're converting it. And I will show you exactly. It's really the same as ratio and proportions, but it allows you to do more in one step or in one problem. And I'll show you what I mean. Look real quick at this tech alert that's on here. Make sure I hear. Excuse me. It says when making conversions between two measurement systems, the answers will usually not be exact, and the accepted difference between the measurement systems is in the range of 10%, either above or below the actual calculated amount. Other factors in calculating approximate measurements do exist, such as the viscosity of the medication, the size of the utensils that will be used to provide the medication. It says, in this text, please be sure that your conversion is as close to the exact amount as possible. So use the conversion factor that will give you an answer that can be administered with the utensil available. For example, in some cases, a teaspoon may be 4 milliliters, but in others, when calculating a teaspoon, the conversion may be 5. Now, for the most part in here, I always tell everybody to use 5 because that's kind of your standard size. That's what you see on like a syringe and things like that. So know that. So for the most part, we're going to use 5, and then you can round from there. You always want to find the measurable amount for the ease of administration. So an example of this would be like, let's say you measure it out, and they're supposed to get let's say they're supposed to get 6 teaspoons. Okay, well, you can't, there's no way you can't measure out 0.6 teaspoons. You don't have anything that's going to measure that. So that, in that case, you just give them half a teaspoon. Okay, so that's an example. You would need it to be measurable. You don't want to put on prescription instructions that they need to take this medicine when they can't even measure that out. Okay, so we'll kind of go in from there. Now, this is going to give 2 ways when we look at how we change conversions, or we're converting from one type of unit to another. So, for example, we're trying to go from pounds to kilograms because maybe the medication is ordered in kilograms, or milliliters to teaspoons because, teaspoons for us, sometimes people like teaspoons, they think they're easier to measure out than milliliters. So those are some examples of when we might use it. But this is going to be a regular pharmacy math. This is a pharmacy tech task, some of this stuff that we're going to be doing. Now, there's really two ways to do the basic conversions. You can use ratio and proportion, and you guys can see that there on 123, 124. And you guys, if you want to use that, you are more than welcome to do that. I know that's something you guys are familiar with. You've learned that in math growing up. But for this purpose, we are going to use the dimensional analysis, which is this next section. Okay, now like it says, dimensional analysis is actually ratio and proportion in multiple sections expressed as fractional forms, and they're written as like a complete equation. So what we're really going to be doing in dimensional analysis is doing lots of ratio and proportions in one long equation. And it's very easy to set up. I think this is the easiest way to do this. Okay, so this is, I'm going to teach you guys how I set this up, how this works for me, and then if you guys want to, you know, this is how I want you to learn it. If you want to go back and use the ratio and proportion method for the way that you do this, perfectly fine. The reason I'm teaching you dimensional analysis and the reason that I use it is because even though in this chapter we're going to have fairly simple equations, when we get on into looking at how many drops per minute of an IV medicine they need over 24 hours or something like that, I mean, it's going to be pretty complex, and that's why I like to use this with the little things, so it's pretty easy when we get to the big, long things. So look at this example that they have here. Okay, it says, to use dimensional analysis, take the example of prescription to be prepared for 250 milligrams of an antibiotic. I'm at the bottom of 124. The available medication is 125 milligrams per 5 milliliters. How many teaspoons should be administered? Okay, so you can look on there, but I want you guys, I'm going to try to write big enough so you guys can for sure see me online as well. Let's see if I can zoom in anymore. I don't think I can. No, that's it. Okay. What I always do is I always write down my information first. I'll write it over here. Maybe you guys can see better. So what do I want to know? What unit am I trying to get to at the end of my equation? Well, this tells us how many teaspoons should be administered. So I want my answer to be in teaspoons. Okay. So now I want to know what medication is available. We know that medication, the dosing amount of the medication that's available is 125 milligrams in 5 milliliters. That means there's 125 milligrams of the active medication in every 5 milliliters of the liquid. So what that tells me is, okay, I've got what I'm trying to figure out, and I've got what's available. Now I need to get from what's available to my unit. Well, I need a conversion unit. Okay, so I know that 5 milliliters is equal to 1 teaspoon. Okay, that should give us everything, but let's just check and see. This is how I like to check. Okay, so I got my info. I always put what I'm trying to get on one end of my equation. I'll put it on the front. Okay, so teaspoon. Let me write that a little bit bigger for you all. Okay, put my equal sign. This is what I'm trying to get. Here's my answer. Now, I always, when I start writing out my fraction for dimensional analysis, I always start with the unit that I want to end up with, because I want to make sure that that unit is on top in my equation so that it pulls over. So I'm going to start right here. 1 teaspoon, 5 milliliters. Okay. Now I want to make sure that I can cross multiply everything else. So 5 milliliters. Now my next one. 5 milliliters over 125 milligrams. And then I need my dose. I need my milligrams. Oh, that's what I didn't write down. I was missing something. Okay, write down your dose. Our dose is 250 milligrams. Okay, so that's our dose. If you want to, if it makes you feel better, you can put 250 milligrams per dose over here, and you can add that over here. Teaspoons per dose. That's still going to give us the same amount. So now I want to make sure that I end up with, I want to cross out all my units that cross from top to bottom. So milliliters, milliliters, I can cross that out. Milligrams and milligrams, I can cross that out. Now I just end up with teaspoons per dose, and that's what my answer, that's the answer that I want to have. So then you can just multiply and divide straight across like any other fraction. Okay, and this one's pretty easy. I know that I can cross out my fives. Those are like common multiples. I can't think of the word there. And then I can cross these out and get 2. So I know that in order to do that, I've got to give them, they've got to have 2 teaspoons of medication. Okay, now if I would have done this ratio and proportion method, it would have looked, I would have had to do a ratio and proportion, you know, to figure out, there would have been a lot more steps involved. So it's the same idea as what we've done, is just puts it all into one thing. Okay, so we'll do another one. Find my eraser. Excuse me. Okay, let's do another one. Let's kind of go on to a different page here. Okay, let's do, a couple of things. 2 things I do need to tell you before we keep going. And that is the difference between the dose and the dosage. I think I missed that at the very beginning. Okay, when this book is talking about the dose, okay, they're talking about what's to be given at a single time. Okay, like let's say the doctor says take 1 pill every morning before breakfast. Okay, so your dose is that 1 tablet, whatever it is, 250 milligrams, 1 tablet or whatever. Okay, the dosage, whenever you hear that word in this book, it's referring to what it takes to complete the order. So if the doctor says you need to take 1 pill every morning for 4 days, then your dosage, okay, what you actually give them is going to be 4 pills. Now, it's not necessarily always the case, so when you hear that word dose and dosage, you really need to look into kind of context and figure out, do they mean the dosage right now? Do they mean the dose? What are they saying? But in this book, I think it was listed, I read it earlier. Excuse me. But that's what it said that it means. Okay, let's keep going. On 128, there's a tech alert, and always pay attention to those tech alerts. I think they're really helpful. Don't confuse the symbol dram and ounce. So that is something to be aware of. Also make sure it makes sense, like it says. Okay, so let's do a couple of these practice questions. Let's do number 3 on page 129. Okay, so you got 2 teaspoons equals X drams. So our question we're wanting to know is drams. That's our unit that we want to know. And our dose, we'll say, is 2 teaspoons. Okay, so we still need to be able to get from drams to teaspoons. So that means we're going to have the conversion factor. How do we convert teaspoons to drams? So if we go back to page 127, there's a conversion on there. It says 1 dram is equal to 1 teaspoon. This one's pretty easy. But if I set it up like I did my other one, okay, I'm going to put my drams over here, my equal sign, and I know my drams, so I've got 1 dram over 1 teaspoon, and I've got 2 teaspoons is my dose, multiply straight across. So 2 teaspoons equals 2 drams. So let's see if we can work out one that might be a little bit more challenging. Sorry, I can't quit coughing. Okay, let's look at number 16. 75 drops, and I'm on page 130, 75 drops equals how many drams? So our question, the units we're trying to figure out is drams. Our dose is 75 drops. So we need to get from drams to drops. Let's see what we can find here. On that conversion chart, it says that 1 dram is equal to 1 teaspoon. Okay, so there's one thing that we know. 1 dram is equal to 1 teaspoon. And we know that, so it's going to be a little bit longer. Okay, so 1 dram is 1 teaspoon. We know that 1 teaspoon is 5 milliliters. Well, we can go ahead and put that up here. So that means 1 dram is 5 milliliters. And then we need to get from milliliters to drops. So 132, there's a conversion chart on there. It says 15 drops is 1 milliliter. Okay, so there's my conversion chart, my conversion factors. Now I'm going to go back down here, put my question in. I want to know how many drams we have, 75 drops. I'm going to start with my drams on top to make sure that I get my drams on top over here. So 1 dram is equal to 5 milliliters, or 1 teaspoon. We're going to use milliliters so we can get to our drops. Now, I know I've been putting like our dots for multiplication in between here, but I actually usually like to use boxes. I don't know why. You can do that however you want to. So 1 ounce is 5 milliliters. And I go up here, I've got my 1 milliliter is equal to 15 drops. And my dose is 75 drops. Okay? Now, the way that I check myself and know that I set up my equation correctly is that I go back through and everything cancels out just like it should. So milliliters cancels out, drops cancels out, and I end up, the only thing I have left are my drams. So I know that I've set up my equation correctly. Now I can just do the multiplication. So, you guys can, well, 5 times 15 is 75, so it's going to be 1. So the answer to this one is 1 dram. Okay, so that is the easiest way, I believe, to do this. And the reason, again, that I like to do this is that it makes sense in multiple equations and multiple different ways that you do this. Let's look real quick at a word question because you'll get some of those. 29, it says, well, that one's too easy. Let's look at 27. A physician writes an order for an antihelmintic, that's a worm medicine, for a child weighing 35 pounds. The dosage must be calculated in milligrams per kilogram of body weight. So how many kilograms does a child weigh? So we're wanting to know kilograms, okay? And what we already know, the info that we have, we don't really have a dose, but we have info, and that is that they weigh 35 pounds. Now what I know is that there's 2.2 pounds in every kilogram. So that's our conversion factor. So I'm going to put my kilograms over here. I know in 1 kilogram there are 2.2 pounds. And I know that this kid weighs 35 pounds. So I can cross out my pounds. Those will cancel each other out. And then I can just do 35 divided by 2.2. Well, we have my. So 15.9 kilos. So I can figure it out from there. Okay. So that's that. Let's keep moving on. Hopefully that is making sense for you guys. Okay, conversions between metric and apothecary. So let's practice some of these. It's going to be the same way, just different conversions. So let's practice one of these. Let's see, we've got, okay, let's look at number 7 on page 139. We're still going to use dimensional analysis. 15 milligrams equals how many grains? So what we're wanting to know is grains, and what we already know is we have 15 milligrams. Now we need to figure out our milligrams to grains. I believe there's 6, I better not say that out loud. Yeah, there's 60 milligrams in 1 grain. You'll notice grains are always written out with the number behind them. And if there's a portion of it, it's usually written in a fraction. So just know that. Okay, so let's figure this out. So we want grains. We know that there's, for every 1 grain, we have 60 milligrams. And we know we've got 15 milligrams.
Christopher Jones, if you're in the building, please come to the office. Christopher Jones, please come to the office. Thank you.
Okay, so this grain then is actually going to be 1/4. That's going to be our answer, 15 divided by 60. Okay, so you'll just, again, look at 22 real quick. Do you want to go over that one? So it's pretty easy, though. Okay, if you'll remember, a cubic centimeter, that's been one of your abbreviations before, 1 cubic centimeter equals 1 milliliter. Okay, so 55 milliliters is just 55 cubic centimeters, cc. Let's look at number 20, actually. We want to know grains. That's what we're trying to figure out. And we've got 0.1 milligrams. So it looks like, so we know that 1 grain is 60 milligrams again. So let's look at this. 1 grain over 60 milligrams, and then we've got 0.1 milligrams. So even though this is a decimal, and even if it was a fraction, it's still going to all go in that little top section there. It's probably easiest if you get a grain and you're converting it to go ahead and put it in a decimal form. I think you'll find that that's probably the easiest way to go about doing this. So this is 0.002. Okay. All right, let's keep going. This next section goes over kind of covers all of them, but they're going to work the same way. Let's do a word problem on page 140, and then we'll be done with this, and you guys can do the post. Let's see. 29. A patient has a prescription for Seconal grains, 1.5. Remember that SS is a half. Okay, the available medication is Seconal 100 milligrams per capsule. So how many capsules do we need to dispense? So what we're wanting to know is the number of capsules. Okay, the medication, the available medication is 100 milligrams per capsule. And the dose that we're looking for, or the dose that the doctor's written for, is 1.5 grains. Now we need to be able to get from grains to milligrams. And we said that 1 grain is 60 milligrams. So let's work this out. So we want to know capsules. So we know that in every 1 capsule, there is 100 milligrams. And I'm just taking my info from up there and playing it in. Remember, my capsules is what I want, so I want it to go on top first. So I can make sure I get that correct. Okay, we've got 60 milligrams is my next one, because I want milligrams to cancel each other out here. put grain, 1 grain at the bottom, and then I know that my dosage is 1.5 grains. I can cancel out my grains there. So I've got my correct units. I ended up with capsules. So I know I'm doing my math correctly. Now I just need to do my calculations. 60 times 1.5 divided by 100 is 0.9. Now, I can't answer this and write down 0.9 because I can't give 9/10 of a capsule. But I can give 1 capsule, and this is within that 10%. So I know that's going to be my answer is 1 capsule. Now, I will say this. You'll get a couple that are on here, and it will discuss this. But if they ask if they can get, let's say that this came out to 0.5 caps. Now, a capsule cannot be split up. You can't have a capsule. It's got powder in it. But if they have a tablet, sometimes you can have a tablet. So if it says that it has a scored tablet, that means it's got a line down the middle of it. And if it has a line down the middle of it, that means you can cut it in half. So if it said, let's say this turned out to be 0.5 tablets. If it's a scored tablet, then yes, you can half it, and they'll be fine. But if it is an unscored tablet, if it doesn't have that line in the middle to make it equal whenever you break it in half, you don't need to be breaking them in half. That's what this book is going to tell you. Okay, so, but other than that, your capsules are usually going to be in either whole or half increment. Not capsules. Capsules will always be whole. Tablets sometimes can be in half increments if it's scored. And that's it for this chapter. If you guys want to, I know I didn't write this in your calendar, you'll just make sure that you do just the odd ones. That I think will be plenty. So make sure you do that. Make sure you look at how you're supposed to round them and so forth. And that's it for this chapter.